And thanks to all of you for taking your Friday happy hour to listen to talk about microbes and good bugs and bad bugs. So as Cindy mentioned, I'm going to tell you about work that we've been doing at the UPenn Veterinary School, where we've recently started thinking a lot about how microbes, both good and bad, influence the health and disease of animals. And what I hope to convince you of at the end of this, first of all, I should preface this by saying this is not going to be a very applied talk. But my hope is that when you leave today, what you'll see is that in the next 5 to 10 years, a lot of these concepts could easily translate into therapies for canine working dogs and for companion animals in general as we go. So the reality is this microbial colonization starts at birth. In fact, studies in humans show that all babies, as they pass through the birth canal, become colonized by the vaginal microbiome. Whether we like it or not, as they're making that transit, they inhale bacteria from the mother's vagina and they ingest it. And so what we know unequivocally is that humans and other animals, when they're born, the first bacteria that their guts are colonized with are bacteria that came from the mother's vagina. So there's this vertical transmission of bacteria from mother to offspring. And I'll bring that up again because we're thinking about that in the context of neurobiology and behavior and cognitive development at the vet school, and I'll get to that, but not till later. But in the veterinary world, this is shocking to physicians, and they find this really remarkable. But to veterinarians, this isn't that surprising. And in fact, in places like dairy farms, this concept of transplanting the microbiome, even though it wasn't called that at the time, from a healthy animal to a sick animal has been done for over a century. And they have a much better name for it. Instead of fecal transfer, they call it transfaunation, so fauna, so giving all the animal life to another animal. And that happens a lot when dairy cattle get ill. When they're ill, they don't make a lot of milk. That's not good for dairy production. So one way to remedy that is to take the rumen contents, so this is the compartment of the stomach where fermentation occurs and really critical for generating energy for the cow to make milk. That rumen is teeming with bacteria that break down and ferment the diet that the cows are consuming. And so you can collect that rumen mush, and just like they did with fecal transplants, you can transplant that to a sick cow, and their milk production goes way up. And so it's a common thing used by veterinarians. So why is a veterinary place a good context in which to start to study the microbiome? Well, I think if you look at any of these top-tier scientific journals that have had lots of articles about the microbiome, or if you look at the New York Times or The Economist and you've seen some of these front-page stories, if you open any of these journals, you will always see that the story either involves humans, which is great, we care a lot about human health, or it involves mice, and that's important too. I just told you mice are great models that we can work with in the lab. But there's something between mice and humans, and at the vet school we think companion animals coming into Ryan Hospital every day are that intermediary. Those are animals that went from being healthy one week to very ill the next. They have spontaneous disease, they have relapsing remitting disease, very heterogeneous presentation and response to treatment, all factors and features that human medicine sees and is interested in understanding. So what do we want to know? Well, we'd like to design a clinical trial that lets us assess what the similarities and differences are in the way that different treatments affect the microbiome. How does a diet affect it versus antibiotics versus immune suppression, the three most common ways of treating, frankly, animal canine IBD and also human IBD. Which of these changes are associated with disease remission? And how does the composition of a dog that comes in with disease, how does the microbiome in that dog look, and can that tell us anything about which treatment they'll respond to best? And so we're designing a trial, we're actually starting the enrollment very soon, where dogs with disease ongoing, where their owners are bringing them into the hospital, will be screened by a full detailed workup. If there's no evident underlying disease other than IBD, then they're kept in. If they find something else, they're excluded. They come back for a second visit for a standard diagnostic technique and endoscopy, where we can actually then get samples for understanding the microbiome that's living right in the gut, and also get fecal samples. If no other disease like lymphoma is evident on the endoscopy, then they stay in the trial. And if they're in the trial, then what we do is we begin all dogs first on a dietary intervention. They all get a hypoallergenic that Royal Canin is providing, hypoallergenic diet, excuse me, and they stay on that diet for 14 days. If they respond favorably, we call that food responsive diarrhea, and we leave them on that food change with no other interventions for the duration of the 6-week trial.